Example 4 on page 288 says, write the ratio of the height of a tree 4 meters tall to the height of a sapling 50 centimeters tall in simplest form. This is exactly like example 3, only they threw a bunch of words at you. So something that is 4 meters tall compared to something that is 50 centimeters tall. Okay, are you guys with me right here? Now, the problem is the fact that we have different units. And if you remember, I said take the larger unit and convert it to the smaller. Take the larger unit type, which is meters, and convert it to the smaller. Because otherwise you're going to have, what, a half a meter here? And a half of a meter is difficult to work with. You want to always have the numbers be whole numbers. So 4 meters is equivalent to how many centimeters, Jared? Okay. Can we simplify this further? Yeah. And you're not going to just write 8. You're going to write 8 to 1. Because if you think about it, 400 centimeters over 50 centimeters. Centimeters cancels out. You're not going to say 8 because you're comparing two items. So I have 8 trees to 1, or 8 centimeters to 1. 8 to 1 is the ratio. Okay? Now, if you did do it the other way, which they show you in solution 2, changing both items to meters, you'll get there eventually. They did 4 meters and a half a meter, and then you would have to figure out what that would become. And if you multiplied both by 2, you would end up with 8 to 1. All right, example 5. This is where it gets a little odd. Does anybody have questions on example 4? Really quick. You guys are good on example 4? Okay. The next example is going to apply to numbers 1, number 2, I think number 3 as well. So here we go. Here's example 5. Jenna plants alfalfa and wheat on 160 acres of her farm. If the ratio of alfalfa acres to wheat acres is 3 to 5, how many of each are planted? Okay. So I want 3 acres of alfalfa. Actually, I'm spelling it wrong, aren't I? Alfalfa. And I want 3 times the amount of acreage of alfalfa and 5 acreage of wheat. So the ratio to be 3 to 5. So for every 3 acres of alfalfa, there are 5 acres of wheat. Now, to express this and actually determine what those actual numbers are, you use a variable. Something like that. Okay? So 3 times x added to 5 times x is 160. 3 times x added to 5 times x is 160. So you take the ratio and break it apart using x as the amount of acreage. Right now I get 8x equaling 160 and x equaling 20. Now what does that tell me? All that tells me is x is 20, right? But I know that 3 times 20 is my alfalfa. Why? Because there it is. 3 times 20 is alfalfa, so that's going to be 60 acres. And I know that 5 times 20 is wheat. So wheat is 100 acres. And if I take this, 60 over 100, does that equal 3/5? Yes. That's how you discover when you're comparing two items how many of each you have. Example 6. If you have 3 items, again, sharing some bit of information. Example 5, they shared the acreage being farmed. But in example 6, they're sharing a triangle's side lengths. The lengths of the sides of a triangle are in the ratio 3 to 4 to 5. 3 to 4 to 5. I'm plugging in that x in the same way I did up there. 3 times something, 4 times something, and 5 times something for a perimeter of, 24 inches. 3x plus 4x plus 5x is 24. So when you have a ratio, even if it looks like that, you can still use the same rules. So 5 plus 4 plus 3 is 12. So x must be 2, right? 3 of those 2's is this side. So how long is the short side? 6 inches. 4 of those 2's is the next side, which is how much? And 5 of those 2's is the long side. 10? So if you took the shortest and the middle side, 6 to 8, you would find it does indeed reduce to 3 to 4. If you took the middle and the biggest, like 8 to 10, you would find that it does reduce to 4 to 5. So if you wanted to check yourself, you could, simply by picking 2 in the ratio list and comparing it to the same 2 in the actual amount. So your answer is a 6, an 8, and a 10 are your sides. That is example 6. Okay. Find 2 numbers in the okay, we're going to go to the problem set now on page 291. Page 291. Number 1. And some of these are deceptively easy. You're going to think they're hard, but they're not. Find 2 numbers in the ratio of 4 to 5 whose sum is 45. So if the ratio is 4 to 5 and I'm looking for 2 numbers, it's just like the triangle problem and the wheat and alfalfa problem. 4x added to what? 5x. So you end up with 4x plus 5x, because we're looking for the sum, and the combined x's equaling 45. So altogether, there are 9 x's, which gives me x having a value of 5. Well, what does that tell me? So then what's the first number? 20, and what's the second number? 4 times 5 and 5 times 5. So that is your answer. Those are the 2 numbers. To check those, if you took 20 over 25, does it reduce to 4 to 5? Then you know you're correct. The 2 numbers, 20 and 25, do add together to give us a 45, and they do reduce to 4 to 5, which is the ratio in question. Okay. How are you guys doing over there? Okay. So here's number 3. Whoops. Together, there are 180 coaches and players. This is number 3. If the player to coach ratio is 9-to-1, 9 players to 1 coach, how many players are there? How are we going to set this up? What do you think? Ben, what do you think you would do to set this one up? So above we were given a ratio of 4-to-5, totaling this. So 4x plus 5x totaled this. Now we're using actual real-world situations. We have a ratio of 9-to-1, totaling 180. So what do you think? Plus? Yep. Perfect. 9x plus 1x is 180. 10x is 180. So x has to equal 18, but that doesn't tell me anything. I want to know how many players there are. Which item am I going to use? Am I going to use 9 times x or x, Connor?
9 times x.
9 times x. Did you come up with 162 players if you threw that into your calculator? Awesome. Number 7, this is the same as example 6. I'm sorry, let's do number 5, shall we? The perimeter of a rectangle is 96 centimeters. This is a little bit tricky. Find the dimensions of the rectangle if the ratio of the lengths to the ratio of the widths is 7-to-5. So here's my ever-present rectangle, 7-to-5, right? 7 being the longer side, 5 being the other side. If the perimeter is 96, the perimeter is the sum of the sides, right? 14x plus 10x is 96. Side plus side plus side plus side. Okay? That distributes everything. Yes?
Could I say how they got the answer?
Go.
I divided 96 by 2, and then I found the ratios by multiplying by 2 or 3 that equal whatever 96 divided by 2 is. So 24x. Yeah, I just did it backwards.
The easier way of doing it would be to simply add up the sides, combine your x's, and then x,
And distribute.
96 divided by 24. Is that 4?
Yeah.
Okay.
So that's
You with me? So if x is 4, what's this side?
28.
Mm-hmm.
And then the other side's 20.
To verify that I'm correct, I can do 28 plus 28 plus 20 plus 20. 56 plus 40. Is that indeed 96? Check. So when you have a rectangle and they give you the ratio of side lengths and they compare it to perimeter, you've got to add all 4 sides, which might seem weird, 7 plus 7 plus 5 plus 5, but they are talking perimeter here. Now, if they were talking area, then it would only be base and height, a 7 and a 5. Okay, you would do it only 2 sides. Now let's go on to the land of triangles. This will be 7. The length of a triangle. The lengths of 3 sides of a triangle are 3, 5, 6. All my triangles look the same. 3, 5, 6. 6. The perimeter is 21. So 3x, 5x, 6x is 21. So 5, 6 is 14. So you're thinking right now, oh, I've got to be doing something wrong because this isn't going to work out evenly. Don't worry. If we divide everything by 14, what do we get, 3 halves? Okay. So every single thing then gets multiplied by 3 halves, and yes, your amounts are going to be fractions. So the short side is 3 times 3 halves, equaling 9 halves. What is that, 4 1/2? You guys see how I came up with that for the short side? So don't always assume you're wrong if you get fractions. This is correct. For the middle side, which is 5 over 1, 3 halves. What do we got, 15 halves? 7 1/2? The last side, 6. And you should have come up with 9 centimeters for that one. So far, so good? So don't think you're wrong just because you come up with weird answers. If you go back and check all of this information and add it together, you should come up with what? 21, right? So 4 1/2 plus 7 1/2 plus 9. Does that indeed equal 21? So you know you're correct. Okay? If you check your work, you will be able to see if you're correct on these quite easily. Concrete. This is number 9. Last one. And number 9 and 10 are almost identical, by the way. Concrete can be made by mixing cement, sand, and gravel in a ratio of 3 to 6 to 8. How much gravel is needed to make 850 cubic meters of concrete? So which one's gravel? Cement, sand, and gravel, right? Cement, sand, and gravel. Look at the question again. Concrete can be made by mixing cement, sand, and gravel in the ratio of 3 to 6 to 8. How much is needed to make this much? Attach a variable to it. Add all 3 things together, solve for x, and whatever you get, you only care about this one. The 8x is the gravel. So 17? 17x? So how much gravel is needed? Construction workers extraordinaire would need to know this. How much gravel is needed? Yes, good. She's right. 400 cubic meters. If I wanted to know about sand or cement or sand, I could find that out as well. But they don't ask that. They ask for this. And if you plugged in your x variable everywhere, like here, 3x is 150, plus 6x, which is 300, plus the one we wanted, and it checks out.